Hello, welcome to this video on GCSE Physics, scalar and vector quantities. In this video we'll be talking about scalar and vector quantities and what they are with examples. We will also be talking about how arrows can be used to represent forces and how we can calculate resultant forces. Physics deals with a large number of quantities. Some of them have fixed values, for example the speed of light in a vacuum, and some can be any value, for example the temperature in a room. A unit is what the quantity is measured in, so meters per second for speed. Quantities are given symbols to make it easier to write down, so T for time, I for current, and Q for charge. It's not always obvious why a particular symbol has been chosen, but you do have to use the correct ones. Units are also given symbols, M for meters, S for seconds. These unit symbols can be combined to make other units, for example meters per second for speed. Quantities can be split into two groups, scalars and vectors. Scalars are quantities that only have magnitude. A magnitude is the amount of something. It is represented by a value, so a number. For example, water boils at 100 degrees Celsius. These are some examples of scalars that you'll come across in this course: power, distance, mass, speed, temperature, time, work, energy, and density. Vectors are quantities that have magnitude and direction. Magnitude is the same as it is in scalars, so it's the amount of something. The direction, it can be given in the following ways. It could be an arrow, it could be left, right, up, down, it could be north, south, east or west, or it could be an angle that's given to show the direction of something like a force. These are examples of vector quantities that you will be coming across in your course: acceleration, displacement, velocity, momentum, weight, and force. A vector quantity may be represented by an arrow. The length of the arrow represents the magnitude, and the direction of the arrow represents the direction of the vector quantity. Here we have a scale that is 1 square equals 1 Newton. This particular arrow is 7 squares across, so that is 7 newtons. And the direction that it's pointing in gives us the direction, in this case, is east. This next example, 1 square represents 2 newtons. And in this example, we have an arrow that is 5 squares long. So applying our scale to that, that would give us 10 newtons. And the arrow is pointing downwards, so we could say this is south, or we could say downwards. In this last example, our scale is 1 square is 0.5 newtons. Our arrow is 3 squares long, which means we have a magnitude of 1.5 newtons, and this arrow is pointing towards the left. Multiple forces can be acting on an object. The resultant force is a single force that can replace all of the other forces and have the same effect. When forces on an object are in the same plane, they can be either added or subtracted to find the resultant force. In this example, our object is represented by the orange circle, and the two forces, 3 newtons and 6 newtons, are acting in the same direction. As they're acting in the same direction, they can be added together to get 9 newtons, and that gives us our resultant force, 9 newtons east. In this second example, the forces are acting in opposite directions, and when they're acting in opposite directions, they need to be subtracted. So we get 6 minus 3, which gives us 3 newtons. So our resultant force is 3 newtons towards the east, because that is the side with the bigger amount of force, and so that will be the direction of our resultant force. A resultant force will cause an object to accelerate, and an acceleration can be speeding up, slowing down, or changing direction. In summary, scalars have magnitude only, for example speed, energy and time. Vectors have magnitude and direction, for example velocity, acceleration, force, momentum. Forces can be represented by arrows, and the length represents the magnitude, and the arrow point is in the direction of the force. Multiple forces can be acting on an object. The resultant force is a single force that can replace all of those other forces and have the same effect. To find the resultant force, forces in the same plane can be added if they're going in the same direction, or subtracted if they're going in opposite directions. And that's all for this video. Thank you very much for listening.